Alright guys, these are your notes for section 6-7. This is the quadratic formula. This is probably one of the most famous things in Algebra 2. And I look forward to it. Okay, here's your journal choice. You can look up a song on how to remember the quadratic formula and you can sing it or play it in front of the class and it will be awesome. Alright, moving right along here. What is the point? We are going to motivate, prove, and apply the quadratic formula. And we are going to solve quadratic equations. And this is just awesome in every way. I just love quadratic formula. It's a way that always works, although I will be surprised when some kids use the quadratic formula when they could factor things. But it always works, so it's nice to be able to solve any quadratic. So let's look at what we got here. It is the way to figure out what x equals if you have this. Here's the kicker. You have to have 0 on one side. So the first thing you have to do is get 0 on one side. This is the graph of a parabola. And you should have two answers, right? Because of the x squared plus or minus. There is one possibility where you might not get two answers. And that would be if your parabola was what we call tangent to the x-axis, but usually you'll get two because usually that parabola is going to hit that x-axis in two spots, and that's where we're looking to see where it equals 0, okay, for y. Okay, this is super fun. Here is the quadratic formula. You do have to memorize it. The two answers come from applying this plus or minus right here, okay? So if 0's on one side and a can't be 0, so you have to have an x squared term. If you have an x squared term and it equals 0, you're going to apply this quadratic formula and you're going to get two answers by using the plus or minus. There is a song to the tune of Pop Goes the Weasel. You will all be singing in class. X equals opposite b plus or minus square root b squared minus 4ac all over 2a. You'll probably sing it over and over while you do your homework, while you write it down. We will sing it a whole bunch in class tomorrow so that you know it. And it's not optional. Everybody will sing. And it's a good way to memorize that lovely, lovely formula. Here are some examples. We're just going to say whether or not you can use the quadratic formula. Okay? Tell whether each of the following equations is in the correct form. Is it ready to go? Is this guy ready to go? And I don't know if you can even read it, so I will write it right above it. 32x squared plus 15x plus 21 equals 0. Can I use the quadratic formula? Sure. I got 0 on one side. I got an x squared term. This is absolutely ready to go. Okay, how about this one? 1/5 x equals x squared. I have an x squared term, so that's good, but I do not have 0 on one side, so the answer of this is no. If I wanted to use the quadratic formula, I'd have to subtract this 1/5 x first. And then I would have 0 equals x squared minus 1/5 x, and then I could use it. But this one is not ready to go the way it looks now. This guy, I have 0.045x squared plus 0.06x minus 4 equals 0. Okay, I got 0 on one side. I got an x squared term. This is ready to go for quadratic formula. This one, we all know if I was to double distribute x minus 3 times x plus 4 equals 0, I would get an x squared term. I have equals 0. Unfortunately, this is not ready to go because it's not expanded. Once I expand it, if I had x squared plus x minus 12 equals 0, I could use it. But as it stands, no, it is not ready to go. Okay, so that's how you could tell if it's ready to use the formula. Now let's actually apply it. Okay, we are going to solve the equation here. I'm going to pull up a little rectangle to do my work on. We are going to use this fun formula. First thing I'm going to do is I'm going to write it down. I'll go black here. X equals negative b plus or minus square root b squared minus 4ac all over 2a. You gotta make sure it's all over it, and you gotta make this b squared minus 4ac is underneath the radical. Okay, so now we just need to figure out what is a, b, and c. A in this case is 1 because it's 1x squared. B is 8, and c is 12. Okay, so negative b, that'd be negative 8, x equals negative 8 plus or minus square root. I usually do the b squared in my head, so that's going to be 64 minus 4, and I usually multiply the a and the c in my head also. All over 2a is just going to be 2. X equals negative 8 plus or minus square root of 64 minus 48. That's 16. Square root of 16 all over 2. This guy is 4. X equals negative 8 plus or minus 4 over 2. So this is the two problems. So I have negative 8 plus 4 over 2, and I have negative 8 minus 4 over 2. What are my two answers going to be? X could equal, this is going to be negative 4 over 2, which is negative 2. And this is negative 12 over 2, which is negative 6. Quadratic formula, not too difficult. Unfortunately, I just wasted about 2 minutes of my time solving this problem this way. You need to remember how to factor. If you can remember how to factor and the equation is factorable, this will be much easier for you. Do you remember factoring by the method we call guess and check? Okay, you make a list for the 12. How can I multiply to get 12 and add to get 8? Well, does 1 and 12 work? No. Does 2 and 6 work? Ding, ding, ding. Oh, if I have x plus 2 and x plus 6, that can double distribute to give me x squared plus 8x plus 12. Now, because this is just representing a number, and this guy just represents a number, one of these numbers has to equal 0 for this to be true, because it's saying something times something equals 0. In order for that to work, one of those has to equal 0. So I have two equations here. X plus 2 could equal 0, or x plus 6 could equal 0. Well, guess what? If I solve these, minus 2, x equals negative 2, minus 6, x equals negative 6. You do not have to use the quadratic formula if you can factor. Keep that in mind, okay, when you're doing this. Sometimes you have to do the quadratic formula because sometimes you can't factor it or you can't figure out how to factor it. But if you can see right away, oh, I know how to factor this guy, then go ahead and factor it. It'll save you lots of time. Okay, let's look at this. Oh, that was sad. Let's look at this next one here. Okay, this one I have some work to do before I even get started. I need to clean this up. So I'm going to double distribute here. 4x times 2x, that's 8x squared, minus 12x plus 2x, that's minus 10x. I went ahead and combined those in my head. Minus 12x plus 2x, that became minus 10x. And now I have minus 3 equals, distribute, 3x plus 12. Have to get 0 on one side, so let's go ahead and do that. I still have 8x squared, minus 3x, minus 13x, minus 12, minus 15 equals 0. Okay, this one is harder to figure out by guess and check, and it might be quicker to do the quadratic formula rather than play with all those factors of 8. So let's go ahead and look at the quadratic formula here. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay. A equals 8, b equals negative 13, c equals negative 15. Really be careful with these signs here. So negative b, or the opposite of b, x equals 13 plus or minus square root 13 squared, or negative 13 squared, is positive 169, minus 4 times 8 times negative 15 is negative 120, all over 2a, which is all over 16. Okay, let's go up here now. 13 plus or minus square root of 169 plus 480, I think. 649, and if I make a mistake, you guys are going to go crazy, so let me double check that. Okay, I got that right. All over 16. Does the square root of 649 work out nicely? Let's check that out. And of course not, okay? So this gives me a nasty decimal, so now I need to think, can I find something that will go into 649? This is back to your geometry days, guys. So I'm going to check those perfect squares, like 4, 16, 25, all those numbers to see if something Divides in there nicely. 36. I'm still not finding anything. 49. 64. I'm almost done trying here. I don't think anything works out nicely there. Okay, so this just stays as it is, and your answer is going to be for x equals 13 plus square root of 649 over 16, and 13 minus square root of 649 over 16. Now, sometimes they're going to ask you for decimal approximations, in which case you would just plug it in and see what you get, because it depends what the problem is looking for, but in this case you can leave it as an exact answer. I prefer exact answers. If the 649 could have broken down, I really would have rathered that, but I didn't even find anything that goes into 649. That might even be prime. Oh, 59 does, but it's 11 and 59, and those are 2 prime numbers. So that one doesn't break down. Okay, so let's look at one more here. Use the quadratic formula to find the intersections of the graphs of x squared minus 2x plus 2 and negative x plus 4. Oh, this is awesome. Okay, in this case, the intersection is where they have points in common. So if x squared minus 2x plus 2 equals negative x plus 4, that is where they will intersect. Okay, so I still need to get 0 on one side, so I can use the quadratic formula. Plus x minus 4 minus 4. So I have x squared minus x minus 2 equals 0. Now it says to use the quadratic formula, but this would again be a good place not to use the quadratic formula. So let's just take a look at this here. That could be x minus 2, x plus 1 equals 0, x squared plus x minus 2x minus 2, okay? So x is going to be, because it's always going to be the opposite of this, 2 and negative 1. But the directions did say to use the quadratic formula, so we are going to go ahead and do that. We'll start up here. A equals 1, b equals negative 1, c equals negative 2, x equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, opposite of b is just 1, plus or minus square root of b squared is 1, minus 4 times negative 2, all over 2a, which is just 2. 1 plus or minus square root of, this is going to be positive 8, this is square root of 9 over 2. Square root of 9 is 3. Sometimes I like to do it this way. 1 plus 3 over 2 is my answer, and 1 minus 3 over 2. That's 4 over 2, which is 2, and negative 2 over 2, which is negative 1, which I got much quicker by factoring. Okie dokie. Let's see what else I have for you. Word problems of time. The other thing I did kind of go over real quick, and I know you guys probably won't think this is very interesting, but I did want to talk about it, is where this quadratic formula came from. This is 6, 7. And I think it was here in the notes. Yeah. All right, here's the proof for the quadratic formula. Basically, this is the equation, right, that we're dealing with. They are going to divide both sides by a, so the coefficient of x squared is 1, and they are going to come up with this quadratic formula by actually completing the square. Okay, so they move the constant c over a, and then they're going to take half of b over a, which is b over 2a, and then they're going to square it, which is b squared over 4a squared. You see this right here and here. They add it to both sides to keep it equal. Then this is a perfect square trinomial, which is what we did when we were completing the square, and it still has this left. The nice thing about solving problems that have a perfect square trinomial is you can square root both sides. So what they're going to do here, which first they wrote this a little nicer, they found a common factor here. They changed this to CA over 4CA over A squared so they can have a common denominator. Then they square rooted it. They square root it, that becomes absolute value, which gives you 2 answers. And this is exactly where the quadratic formula comes from. It comes from completing the square after you get a 1 in front of the x squared. It's pretty interesting, and it is a pretty famous proof, and I do think you can understand it. Okay, so that's all I have on the notes for section 6-7, and we will work on quadratic formula when we come back to school. Thanks.